So now that we've talked about the fundamentals of streams and the benefits of streams, what we're going to do now is we're going to talk about operations that create a stream. So these are sort of factory operations. We're also going to talk about so-called aggregate operations that are these higher order functions that are passed a behavior that transforms or does something, filters or in some way manipulates the elements in a stream by applying a behavior to each element. So let's start quickly by giving an overview of operations that create a Java stream. And I'm going to give you a quick tour here, and then we're going to go through this in much more detail later, especially when we talk about the concept of splitterators, which are really cool factory methods that are used to make streams out of things like collections and so on. So what is a factory method? Hopefully you're familiar with the factory method pattern from the Gang of Four book. If you're not, just take a look at that link. But a factory method is something that creates something. And the purpose of a factory method is to separate the creation of something from its subsequent use. And as often the case in real life, the way something is made may be messy, may be complicated, but the way it's used could be very simple. And that's why we have factory methods, to hide the way in which things are created. It's kind of like the old cliche, you don't want to know how the sausage is made, right? You might enjoy eating sausage, or maybe you don't enjoy eating sausage, but whether you enjoy it or not, you probably don't want to have to think too much about where it came from. So same thing is true with factory methods. So here's an example of a factory method, the of factory method. And what of does in this case is it takes a list of names, takes an array of names, and it converts that array of string names into a stream of strings. And so that's the purpose of the of method. And more generally, it takes an array of type T, whatever type T is, and it turns it into a stream of type T. So here you can see we have an array of Horatio, Laertes, Hamlet, blah, 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 other Hamlet characters, and we have the of method turn that into a stream of these things. Okay, so that's one way to do things. Of is a pretty interesting factory method. So here you saw it worked on an array of strings, but it can also work on other things as well. So here's an example where we might have lists of strings. So let's say, for sake of argument, we split up the character names in Hamlet according to maybe by gender, or maybe by importance, or maybe by good versus bad, or who knows, whatever you want to do. You might have different lists. And you can also then say stream of list 1, list 2, list 3, etc. So it's not just going to be an array of strings, it could also be an array of lists of something, lists of strings. And this is pretty cool because we take all the lists of strings, so in that case we would have a stream of lists of strings, and then we can use another operation that we'll talk about a little bit later called a flat map, and we use flat map to take the stream of lists of strings and turn it into a stream of strings. So it kind of flattens it out, kind of takes something that's structured and makes it in its more elemental form. So we'll talk about that later as well. Flat map's a pretty cool method. There are lots and lots of factory methods that create streams, and here are just some of them. There's even more than, I think there's even more than this. But these are just a few just to kind of get things going. And we'll talk more about the common factory methods and the more advanced factory methods a little bit later. These are the factory methods that we're going to focus on primarily in this course. I'll show you some examples of these other ones later just so you kind of have an idea of what they are, but these are the key ones. By far the most common methods we're going to look at are stream and parallel stream. And stream and parallel stream take collections and convert them into streams, sequential streams, and parallel streams, respectively. There's also some other stuff that we'll look at, like split as stream, which works with regular expressions. We saw the stream of stuff already. And then there's this other cool kind of helper method called stream support.stream, which is a factory method that takes a splitterator and then turns something, whatever the splitterator is, it converts that into a stream to either be sequential or parallel. So that's also pretty cool. So that's a very, very quick overview of how you get streams, so operations that create streams. And like I said, we'll talk more about these things later. Once you've got a stream, then you do stuff with a stream. And that's really the interesting part. The bulk of the Java Streams framework is this melange, this grouping of many, many methods called aggregate operations that apply behaviors to each element in a stream. And so that is a form of so-called behavioral parameterization or behavior parameterization. As we've talked about a number of times before, a behavior is implemented by a lambda expression or a method reference corresponding to a functional interface. So that's what gets passed in here to the aggregate operation. And we'll take a look at lots and lots and lots of examples. Here's a very simple example just from what we've been looking at. Here's a method reference to the capitalized method, which takes a string and converts the string into something that's consistently capitalized. And so what that'll do, just as a simple example, if we have a stream that looks like this, we've got Horatio with a lowercase h, Hamlet with an uppercase h, it'll put Horatio with an uppercase h, and of course Hamlet stays the way it is. So it just makes sure that everything has consistent capitalization. And that's an example of something you could apply to each element to capitalize it in a consistent way. Aggregate operations can be composed together to form a pipeline of processing phases. So this concept of a software pipeline is a very common pattern. It's called the pipes and filters pattern. It appears in software systems for very, very many years. Here's a simple example from everyday life where you might have a water filtration system. If you don't trust your drinking water, or you want to have better water and you don't want to kill the planet by buying bottled water. And I sometimes speculate that bottled water probably comes from someone's tap, but that's just my conspiracy theory. But be that as it may, if you don't trust the water, the source, you would pipe the water through a series of filters, and they will do various things to get rid of impurities, blah, 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 blah. So that you can imagine the water flows through, and you end up with something at the back end that is tastier than what comes in the front end. Can anybody think of any other example of a pipeline that you're familiar with, perhaps from computer software, computer systems, operating systems? The what? The processor. Oh, like a pipeline, yeah, at the instruction level. You'd have instruction parallelism and pipelining and stuff like that, yeah. Modern hardware has pipelining in the CPU and the cores to do various things in parallel. How about some software examples? Anybody think of some software examples that you might have run across, especially if you've taken the operating systems course? Does anybody know what? Yeah. The Unix or Windows shell. If you ever play with the shell, like the Bash, the Born Again shell, or C shell, or K shell, or TC shell, or even the humble DOS prompt. The DOS command window thing. You can run a command, like a good one would be cat. You can cat a file, which will print the contents of the file. And then you put that little vertical bar, and you can pipe the output of cat into the input of something else, like you might pipe it through other wonderful obscure tools like grep, or awk, or sed, or tr, or sort, right? There's all kinds of things. And you can assemble together a pipeline of processing stages where the input of one stage is the output of the previous stage, and then that stage does some processing, the filter does some processing, and then it sends the data through a pipe to the next phase. So basically the same pattern. There's lots of other examples. We'll talk about some other ones shortly, but that's the basic idea. Okay, so obviously the whole point of this is the output of one aggregate operation is the input into the next one, and we can chain those things together in a very stylized way. So just like you see here, we take the input, we filter it, the output of that is filtered so that we only have things that have a lowercase or uppercase h. We then go ahead and capitalize things consistently. We take the output of all that, we sort it, and then we print it out. So it's just a nice little flow through this pipeline of processing stages. Now, something we'll talk about probably today, if we have time, is this concept of internal iteration. So what you see here is basically a fluid set of method calls. This is what's called a fluent interface style, where we basically compose these things together. So dot of, dot filter, dot map, dot sorted, dot for each. That's called fluid interface. And what's happening here is that the moving of the data from stage to stage is taking place invisibly and internally Unlike collections, which historically have been iterated on explicitly using an iterator. And you guys just got done implementing an iterator for assignment 1B, and that's an example of an external iteration mechanism, because of course you use it by externally getting an iterator to your collection and then going and saying, while has next, do something with the results, and you keep iterating over it. So we'll talk later about internal versus external iterators, but one of the cool things about streams is that they have so-called internal iterators, so they're invisible to you. And that provides certain really cool benefits that we'll also talk about later. Okay, so that's a quick overview of some of the common operations in a Java stream.